Hey, everybody, and welcome to another session with Smart Buildings Academy. This is live session 434 in the maintenance zone. Today, we're going to look at the hopefully best practices for BAS upkeep. Have you ever walked into a building and seen this? I mean, look at that. I have. I've walked into a building and I've seen this. And we'll talk more about this particular case this coming Friday for another session. But what's the first thing you think when you look at this? I was called to come look at this Jace because they just put a cooling tower on the roof. They tied it into this Jace and they couldn't get the cooling tower to work. I wonder why. Well, that's what we're here to talk about is BAS maintenance. So let's get started. When we talk about BAS maintenance, we want to look at several things, but let me ask you another question. Have you ever seen this? Look very closely at this panel. It's not the prettiest panel you'll ever see. And have you seen this? What are all the difference, huh? Who has the better maintenance program? That's the burning question here. First two guesses don't count. Yes, this guy does. No, this guy doesn't. I've seen this before too. Now, both of these weren't taken at the same place. This one in the earlier picture I just showed you, but it was at a world-class baseball stadium. If I told you the name of it, you'd recognize it. So what is maintenance about? Effective BAS maintenance is often ignored, but it can yield many benefits. For example, system performance. Regular maintenance keeps the BAS working, and it eliminates downtime and system failures and building interruptions. It also improves energy efficiency, as well as eliminate energy waste. You optimize energy use and you lower your utility bills, you maintain your sensors, actuators, control algorithms, and building systems. And I'll give you an example. In the middle 2000s, I was asked to go to a particular moderately famous international aircraft manufacturers training center and do a schedule for them to help them improve their energy efficiency. When I walked in, the pictures I showed you earlier, everything looked like that. Maintenance was not done in this building. By improving, by troubleshooting and pointing out all the things that we found and then applying a schedule, we were able to increase energy efficiency. We also improved comfort, occupant satisfaction, including air quality issues. We looked at equipment longevity. If you don't maintain your equipment, it's not going to last long. It's like anything with moving parts. If you don't maintain it, it's not going to last very long. So minimum maintenance requires that you have regular inspections of everything that you have in your building. You look at it on a periodic basis. You do calibration and testing of things like pressure differential sensors, test and calibrate your temperature sensors, test and calibrate your PID loops, things like that. You should do software updates every chance you get. If it's necessary. I want to qualify that. If you're going to do software updates, make sure the software update is called for. Don't just do a software update just to do a software update. You can break things. But if there is a software update that applies, you do that during a maintenance window. Inside the panels, we saw that first panel that was all nasty. Inside the panel, it needs to be clean. It needs to be as dust-free as it can possibly be. Keeping the panel clean and dust-free Dust and debris can accumulate on sensors, they can accumulate on controllers and equipment. You regularly clean and dust them to keep them running at optimal running state. The thing is if dust and debris and dirt accumulates inside the controllers, even though they're in a panel, the stuff can get inside the panel. So when you clean the controllers out, when you clean the panels out, you reduce the risk of dirt accumulation. Dirt tracking, dirt will conduct electricity, dirt will conduct close a circuit, complete a circuit. So what you need to do is make sure that the inside of the panel is clean and vacuumed out. And I'm going to show you the kit that I used to carry when I did BAS maintenance. You want to document everything that you do. This is good for several things. One thing is if you're like me, you have the world's worst memory. If you document what you did, when you did it, how you did it, the next time you're there, you'll know what you did. You'll know what corrections you made, so that if you have to undo anything, you can. Another thing good documentation does is it plans for the next guy. In case something happens and you can't be there, good documentation will tell the next guy, this is what I did, this is how I did it, this is where I did it, and be as detailed as you can. Provide a sketch or drawings or anything like that. Documentation should be archived with the place where you work, so that if something comes up, somebody can go to that documentation and tell what you've been doing in this building. Training and knowledge is probably one of the key elements of maintenance, believe it or not. Training on many levels. One, if you're not trained, you can't maintain it very well. So you need to get trained. And that's really what SBA is about, is to shore up your weaknesses if you have some. Check out SBA, and I'll get into that in a moment. Training and knowledge applies all across the board. You need to tell the maintenance guys that you're working with what you did, how you did it, why you did it. Why is very important. Teach them how the equipment works. So you'd be amazed how many people don't know what they don't know. And it's better to provide too much information as opposed to not enough information. When the building manager looks at your records and and I'm not just talking about the invoice you send them. The invoice can cover general things, but when you make a copy of the documentation and you hand it to them, then you explain to them, this is how this works, this is how that works. Explain what is your voting system all about, why is the voting system important, why does it work, or explain why you maintain these pieces of equipment versus those pieces of equipment today. There's a time and a place for everything. You don't really focus, for example, on a boiler system in the middle of summer. You look at the chiller plant, and vice versa. In the middle of the winter, you look a lot at the boiler system and a little bit at the chiller plant. What you're doing with training and knowledge is you're sharing what you know with the people you're working with. Those are the maintenance people, the building managers, and even your peers. If you have peers that need help learning how things go, it's your job to show them how to accomplish things. And then collaboration. What is collaboration? This is a before, during, and after situation. Mostly a before. Everybody involved with a maintenance program needs to know what you're going to do, how you're going to do it. And a collaborative environment includes asking the building manager, what issues are you facing? What are you looking for? What do you want to see happen? What isn't happening that should happen? Because basically, you're answering all the questions that a BAS system tries to answer. Do you want it on or off? Do you want more of it or less of it? Where do you want it to happen? When do you want it to happen? Why is it happening, and how is it happening? You need to convey that information to all the people you work with, and be receptive to any feedback. Don't try to shove down their throats something that they're not comfortable with. So a collaborative environment, everybody knows what's going on. Everybody knows what you're doing. You have a plan, you have a program, and you're very aware of what your client needs are. This is something I cannot emphasize enough. You can maintain stuff all day long, but if your client has issues and you don't bother to ask them what those issues are, you're setting yourself up for failure. So make sure you work with the client, collaborate with the building engineers, with the building owner, with the building manager, with your supervisor, with your peers. Plan what you're going to do what you planned, and then tell everybody what you did. That goes back to training and knowledge. I want to talk about two types of maintenance that I've been involved with that one everybody's aware of, and another one is a up and coming activity. So let's start with preventive maintenance. Preventive maintenance prevents equipment malfunctions by scheduling inspections, activities, and replacements. So if I need to replace a pressure differential sensor, I can schedule that. Then I can replace it. That's part of your maintenance process. Preventive maintenance aims to avoid unexpected equipment breakdowns and optimize performance. While you're there, you're looking for what can break, what might break, what will break. This is why you put your hands on every part of the BAS system during a maintenance cycle. You can look and see, well, it's not messed up now, but I can see where this is loose and it can cause problems. That's what you do. You tighten it, you tweak it, you correct it. That's preventive maintenance. So preventive maintenance includes scheduled inspections. Equipment is regularly inspected to identify any of the signs of wear, damage, or potential issues. Then you have planned maintenance, specific maintenance tasks, such as today I'm going to lubricate. I'm going to lubricate the motor. I know that's that's a bad example. That's not a BAS thing. Today I'm going to test the VFD drive. I'm going to take it through its paces. I'm going to make sure everything's right and tight. I'm going to make sure that it ramps up as it should. It slows down as it should. We're just going to go through the VFD drives today. So you plan things like that. And the reason you plan them is because you don't want any interruptions to any equipment to affect the tenants that are in the building that you're working on. So there are some tasks that you really have to plan ahead. When I replaced, for example, a controller on a fan-powered box in a building in Colorado, it was on the 11th floor. It was an investment firm. They were planning meetings. So I had to plan my controller replacement around their meetings. Another example, Dish Network in Colorado, I needed to replace several temperature sensors, but it was in a call center. And they have hours during the day where they cannot be disturbed. So I had to plan my maintenance task around the call center activity. Other types of planning is if you have to bring in someone to work with you, like if you're maintaining a boiler system, for example, you want to have a boiler tech with you when you work on that boiler system, or a chiller plant. You want to have a chiller tech with you when you work on that. So you plan when you're going to do certain tasks. That's a very good idea, is to plan ahead. So time-based or usage-based maintenance has to do with every so many months, I need to check filters, or I need to check belts, or I need to check just to make sure the rooftop units are working. Just to, every so time-based or usage-based, how long has something run? If I have a lead lag sequence on pump motors, I want to check how long has pump 1 run versus how long has pump 2 run. Do I need to tweak the schedule so this is a more even distribution of run times, things like that. So time-based and usage-based has to do with how long something has been operating without interruption, or if it has a lead lag sequence or something like that. You want to check on it when it's not in use and the other devices in use. Like if pump 1 is running and it's scheduled to run, you can maintain pump 2. Check the VFD drive, check all the connections, check the CT, make sure it works. Things like that, time-based and usage-based management. And then the big thing, and that's what preventive maintenance is all about, focusing on preventing failures. As you go through the system, you want to inspect everything that you're looking at the VAV boxes, fan-powered boxes, rooftop units, makeup air, whatever it is, you're focusing on, do I see anything that's loose? Do I hear anything rattling? Is it not performing the way? Is the startup sequence not working? Are the valves not opening? Do they need cleaning? Are they dirty? Filth is a pretty big deal, and it's often ignored terribly. So look at focusing on what might fail. These are things you really need to look at. Um, Now let's compare preventive maintenance to predictive maintenance, which is a whole nother animal. They're very similar in some cases. You're still preventing things from happening, but predictive maintenance uses what's called analytics. Predictive maintenance employs real-time monitoring, data analysis, and condition-based indicators to forecast equipment breakdowns or performance deterioration. It optimizes maintenance and reduces expenses by identifying faults before they fail. I'm going to give you a really good example. Real-time monitoring. I had the privilege of working for several years, about 3 years, with an HVAC company in Greenwood Village, Colorado. They had an analytics department. What the analytics department does is they work with clients and they put monitoring equipment on everything that they're allowed to put monitoring equipment on. For example, if they put the right equipment and get the right feedback, they can tell if the damper on a box is stroking completely or not stroking or not closing completely. They can look at differential air pressure on a filter and tell if a filter is about to be dirty. They can measure discharge air temperature versus set point for the discharge air temperature. They can measure room temperatures. They can measure the lifespan of a belt. They can look at the current on a motor and see if the motor's performing. If the current and motor usage goes up, then there might be a problem. So real-time monitoring means they're looking. They have equipment that's looking at the real-time performance of all the BAS parts and pieces that are in the building, and they can predictively tell you based on its performance what it's doing and what problems it might have. Data analysis is where they're able to take the data they collect. Let's say you have a data center and you have analytics going on in that data center. They can tell you during time of day what your peak usage is, what your minimum usage is, how much deviation in throughout the data center you have on temperatures, because temperatures need to be fairly even in a data center. They can tell you how often the cooling system has to run to maintain temperature. They can predict when things might fail based on the performance. So the analytics department is constantly analyzing the data using algorithms that can predict when things might be breaking. And they can actually print out a report saying that to the maintenance guy, next time you're there, check on the following devices. And they'll give you a list of devices. I've done this with an analytics department where they send me a report 3 days before I go to a site for maintenance. And the report will tell me why you're there. Look at this air handler. It doesn't seem to be putting out the air it should be. Look at this VAV box. It doesn't seem to be maintaining temperature and air pressure. Look at the fan power unit. Look at the boiler. Look at it. The analytics will tell you where a problem might be, and your job is to see if the problem is real or the data analysis is an error. Most of the time, it's pretty accurate. Condition-based maintenance, and this goes back to data analysis and real-time monitoring, mostly analysis. Condition-based maintenance deals with activities that are triggered based on the analyzed data, and the condition indicates whether a predetermined schedule should be made on maintaining that piece of equipment. So condition-based analysis. I had a bank in Colorado that had 2 floors, and the analytics department was able to monitor every box, every fan powered box, the rooftop units, the makeup air units, the exhaust fans, everything. So before I went there, this goes back to sending me a report that says And it gives a grade. This is a cool thing about it, about the analytics report. It gives a grade for every box in the building, for every piece of equipment that's being monitored. It gives it a grade. And A means this thing is running. 90 to 100% of the time, it's running really well. And it's color coded, or if it's not running really well, you get that in the report. This one's running okay, but it could probably use some looking at it. And it categorizes things based on the worst performer to the best performer on the report. And that report is what I used in this bank to know what I need to look at first, know what I need to look at second. It actually sorted my triage table for me. I didn't have to go in there and guess. And this is a beautiful thing about predictive maintenance and analytics. It's something that if you don't have an analytics department, build one. If you can't afford to build one, work with somebody who does analytics and will work with you on getting the reports that you need. You can get condition-based maintenance because the analytics, the analysis is done, will print the report out and tell you, you really need to take a good look at this. So what does that do? Is it minimizes downtime because you're able to predict what could be coming. I'll give you a great example. We, in this same bank, all the boxes on the second floor were saying, I'm starving, I'm starving, I'm starving. The analytics department was able to give me a report that told me you might want to look at the supply air for that whole zone. So what I was able to do with that analytic report was go to the roof, and using measurement tools and other things, I was able to determine that the fan size was not able to blow enough air. It needed to be sped up or have a better fan put in. We would not have caught that. We would have been chasing our tail for weeks looking for why are the boxes starving? Are the dampers not working? Is something not working? The bypass damper not working? What's going on? Once we eliminated all the obvious causes, we were able to get up and look right at the fan itself and determine that the fan was not the right size fan for this application. It turned out that 5 of the rooftop units in this building had undersized fans. We were able to see this through the analytics department data analysis report. So when we planned on, we replaced one fan at a time. And so we minimized downtime because of the analytic report, and we were able to schedule when we were going to replace each fan. Minimizing downtime is a huge benefit of predictive maintenance. And cost effectiveness. I know up front it costs something to put an analytics system in a building. Yes, it does cost a little bit, but in the end, the money you're going to save through predictive maintenance far outweighs the cost. Your return on investment will be significant because you're able to get ahead of maintenance problems instead of playing catch up with maintenance problems. I showed you that first gutter and I showed you that first panel. They were both nasty. That is not predictive maintenance, and that's not preventive maintenance. When you get to that, I laughingly called it post-ventive maintenance, meaning the disaster's already happened. My job is to clean it up. Then we can maintain it. What predictive maintenance does is gets you way ahead of the curve and helps you troubleshoot problems that are likely to come up before they come up. The difference between this and preventive maintenance is with preventive maintenance, it relies mostly on what you see at the time you're looking at it. Predictive maintenance can get ahead of that and look at the performance of every item that's being monitored and give you a predictive report on what is going on inside your building. So I'm going to show you my BAS maintenance bucket. I had a 5-gallon bucket in my service truck, and I carried that everywhere I went. Inside the bucket, I had a roll of cleaning towels. That's what that is. I also had an anti-static cloth. The cleaning towels were to to clean off the panel and anything metal, stuff like that. The anti-static cloths were to get the big chunks of dirt off the controllers, clean off parts that are more sensitive to static than, because paper, no matter what, you're going to get some static on the paper. So what else did I carry? I preferred Windex because it doesn't leave behind too much residue. A lot of cleaners leave a film behind, and you can see that film when you wipe it off and dry the panel. Some films will track and close the circuit. So you want to be careful what you use as a liquid inside of a panel. But I would spray the liquid onto the towel, and then I'd rub it around inside the can and clean the can out. If the can had big chunks, I had things like this. I had a little portable vacuum cleaner that I carried everywhere I go. And I also carried, and I want to emphasize this. I want to tell you a story about this brush right here. This brush is coated with carnauba wax. Carnauba wax is what's used in what's called a California car care kit. Carnauba wax will not track electricity. A lot of other waxes will let electricity track, but carnauba wax does not allow electricity to track. In other words, it doesn't give a path for electricity to follow. A lot of waxes do. I have actually pulled giant switchgear breakers out of substations and used carnauba wax on switchgear breakers because it doesn't track, but the breakers have to be clean. And if they have dust on them, you can get static electricity tracking in a short circuit. That's why I use carnauba wax. I just wanted to mention that. One thing that I didn't show on here that I wish I'd remembered to show you is I carried a series of paint brushes. I had a 1/2 inch, a 1 inch, 1.25 inch. I had a 3 inch, I had a 4 inch paintbrush with soft tips where I could dust out the inside of the panel. Then I could get my carnauba wax brush and clean it, and you'd be amazed at the difference it makes. I'd make sure the panel is clean, dirt-free. I would go to every lead inside the panel and pull on the wires to give them the tug test to make sure they're terminated properly. But while I was there, the point behind this slide is, while I was there, I stopped, pulled out the bucket, and made sure every panel I put my hands in was clean, or as clean as I could make it. Now, some of them I would have to schedule because of the amount of dirt and stuff that was inside the panel, and there would be some interruption. But mostly, when you're doing maintenance, you can stop and clean the panel. So what should you check? There's all kinds of things to check: your front end, the mechanical rooms, the panels, all the controllers. And if you look at this list, you'll see there's a lot of temperature sensors and a lot of sensors on here. Sensors drift. So you want to check the sensor's actual reading against their set points. You want to check this temperature reading against a baseline reader. When you do maintenance, make sure you have some spare sensors with you. And when you test temperatures, make sure that the instrument you're using to compare temperatures with has been calibrated, has been certified and calibrated, because you don't want one bad sensor telling another bad sensor what to do. You want to look at your temp sensors and use it against a baseline sensor, that a sensor that you know is clean, is worked, is calibrated, and is accurate, plus or minus 2%. So there's just an awful lot here on this list to look at. A lot of stuff there. What else should you check? Conduct overall visual inspections, verify control schedules, verify your set points, resetting and cleaning time clocks. There are several kinds of time clocks. I'm going to jump on that one. Today, they're all electronic, and most of them can now call home and check against a certified time standard. This list, there are manual time clocks that you'll need to check and clean, though. You will see those on lighting circuits especially. Checking gauges, check control tubing on your pneumatic systems, or if you have differential air pressure, make sure your tubes are right, tight, and aligned perfectly, and not swapped. You'd be amazed how many people swap tubes thinking they're helping when they're not. Check outside air volumes, check dead bands, check sensors. See, there's just an awful lot of things to check. So before we wrap it up, I want to show you an example of this company that I worked with. Um, I got to work with them, and they had this really nice spreadsheet that they used. I can't mention their name because I didn't get permission to mention the name, but I did get permission to use this sheet as long as I took their name off of it. This is the front page of they have a check sheet that they do their maintenance on. That's what I'm going to show you is their check sheet. You can do PM frequency based on monthly, quarterly, every 6 months, every year, or it could be an initial checkout, that sort of thing. So you put in the PM frequency, you put in the type of control system you're dealing with. Is it Johnson Controls? Is it Allerton? Is it Siemens? Is it Distech? What's the brand? On the cover page, you include the site contact. Who's the guy you're going to talk to? What is his phone number? Are there any relevant dispatch notes? Does your dispatcher want you to look at something that the guy, your site contact, mentioned to the dispatcher? Hey, Dave, while you're there, look at the boiler system. Is there analytics in the building? If there is analytics, it's a yes or no question. If you have analytics in the building, did you get the analytics report before you showed up? If they don't have analytics, you don't have to worry about it. Then you put your name, the date, how to get into the building. Some buildings have little key lock boxes. You open the box, pull the master key out, unlock the door, get in where you need to go. Site notes include things like the front end is located in Bob's office, or the supervisory controller is located in the mechanical room 5. And then you get into who's the mechanical contractor. If you don't work for a company that is a mechanical contractor, but you work in parallel with a mechanical contractor and he's supposed to meet you there, that's where you put that information. And then on the cover page is any additional information that you may want to include while you're there. You have to keep in mind, I almost said something I shouldn't. You have to keep in mind who's going to see this report. So you don't want to put things on here like, boy, Bob is sure a jerk. I hate working with him. You don't want to put that on there. But you want to put things on there like security required to enter room 5, or you want to put additional information like parking is available for us only at the back of the building. Here's where you go in, stuff like that. Additional information. So the first thing that this company looked at was the workstation. And the first thing they did, and this is a rule I have, you back up the workstation every time. Anytime you do anything, the first thing you do when you sit down is back up the workstation. If you haven't done that, you haven't done maintenance. Back the workstation up, keep a copy of the backup, give a copy to the building manager if it's okay to do that. Keep a copy for yourself, and keep a copy at the company you work with, because you may not be returning to this place and they may need a copy of the workstation. While you're at the workstation, you do things like check the operating system, make sure it's still licensed. I've seen plenty of applications where the front end is no longer licensed, or they've gone to a different Windows operating system or something unusual. So make sure that everything's up to date. A warning on Windows updates, especially if you run a JACE. There are times when you do a Windows update, it resets the machine ID, and your license has to be, and the JACE has to be reissued for that. There is a fix for that if you install JACEs. Talk to your dealer about the fix for Windows updates. But make sure your software is updated and all that. And when you're in the front end, however many JACEs are listed, if you have JACEs, or if you have other supervisory devices, make sure that the time synchronization is happening between the workstation and the supervisory equipment. Make sure that everybody's on the same page time-wise. This one here, logging alarms, this is a big deal. And what I'm pointing out here, the reason I'm doing all this, what I'm pointing out is there is a method, there is a way to logically go about a daily maintenance program where you look at the front end, you look at networking devices, you look at different equipment, you look at control panels. The reason I point this out is because earlier I talked about what do I look at? When do I look at it? How do I look at it? What pieces of equipment need to be looked at? What this does is gives you a structured approach to doing that. I want to mention something about database maintenance while I'm on this page. I had a talk with a coworker recently, and he pointed out that a lot of logs and a lot of histories and things like that take care of themselves, and that's true. They roll over after so many records, and then they clean themselves up. But there are an equal number of systems out there that require an external database like MySQL or some other brand of PHP SQL, different brands of SQL depending on what you do. And I know this from experience. I've worked on several different types of systems that have an external database running. That's the database I'm talking about maintaining. Go to that database, and it should have a cleanup feature in it. If it does, clean it up. If it doesn't, Google's your friend. Find out how to clean that database up. So what are you cleaning up when you clean up that database? If the database stores records of trend logs, histories, alarms, things like that, and all of that's been taken care of, the database can get bloated and slow down and quit performing once it's reached a certain number of records. You want to reduce the old records, and many databases will ask you how far back do you want to delete, and how much do you want to keep. So you have to use your judgment on that. But you keep the database clean, it'll speed up the database, it'll keep better records if you do that. Then there are other things like verify communication on all networks, make sure IP addresses work and are communicating, make sure the battery backup system's working. If they've changed users, you update the user and remove passwords. If it has remote access, make sure remote access is working. If it emails alarms, make sure the email's working. In other words, this is just basically while you're at the front end, you're looking at all these items and you're making sure the front end is happy. And you'll see this repeated, some things repeated, like logging all IP addresses or battery backup. Some of these are repeated activities, but you're dealing now with network devices like the JASes themselves. I'll give you an example. The city of Glendale, the Glendale city offices includes a sports complex, a high altitude training center, a rugby field. It includes several party rooms. It includes a gym. This building had, I believe, 6 JASes. So that's what this page is all about. I went to this page and I made sure I backed up all the JASes. I made sure that everything's working, that it doesn't need any updated jar files. I verified that it's receiving time synchronization. And with a JASe, you can set up each JASe to individually monitor the time if it has access to the internet. Otherwise, set it up to keep the time off the server. I made sure that all the JASes, if they were to share data with each other, I made sure that they could. And then I made sure that the JASe itself could see the workstation. Then I would list all my networking devices right here. I would talk about the device's address, its ID, what its IP address is. I'd describe where the JASe is located, what things I need to look at, stuff like that. And there are different activities. It's either complete or incomplete or doesn't apply, like that. And then I just put my name and date, stuff like that. So a network device is, that's what that page is about. Here we have the equipment itself. And this is one place where I have a criticism of this page. But it worked for that company. This page worked for that company, but I would have included, and I'll get to this in a second. First, I make sure that all the devices the controllers are communicating with the JASes. I make sure the JASe can see it and that it can see the JASe. What is supposed to happen is listing all the field devices. And so I would put that down here. There's not room on this page to list all the field devices, but I personally would go through and I would include where the field device is, what it controls, where it's located, in any other pertinent notes, including its if it's IP addressed or it's BACnet MSTP or LAN. I would include its device ID and addressing information, stuff like that. So finally, when I went to each control panel, I looked at where's that control panel located. And I would make sure that it's clean. I would make sure the panel is clean. I showed you my bucket. I'll get in there and clean the panel out. I verified that the drawings are current for that panel. A lot of times, BAS companies will put the drawings in the lid. They'll put a big envelope or something to hold the drawings. They'll put the drawings in the lid. That's what should happen. 99% of the time, that's not true. If you have drawings, make a copy of the drawing for that panel and put it in the panel. If you don't, use your own judgment. It's good to get a copy of the panel. Otherwise, draw the panel and draw what it does. Find a way to do that. You want to do, this is something you may have to plan, but you want to do a point-to-point inspection. And using a red pencil, when you point-to-point inspect the controller, is this temperature sensor working? Is this damper actuator working? Then you redline what's not working on your copy of the drawing, and you make notes. I need to fix this. And you put notes here, what I found, HU1 controller not working, replace, something like that. And the nice thing is this expands as you fill it out. So you put in what you found and what needs to be done. Tighten electrical connections. This is really important and overlooked a lot of times. With every controller that you look at, do the tug test, pull on the wires, make sure that they're terminated right. Make sure there's no little stray wires sticking out from the terminal, because they will touch other wires if you move them or if there's vibration. Make sure there's nothing unusual going on with the wiring, like skinned wires or nicks. Make sure the screw is tight, but not pipe fitter tight. I've seen non-low voltage electricians come in and stick their screwdriver in and turn it until you can hear it squeak. That's too tight. It doesn't need to be that tight. So make sure that they're not just tight, make sure they're properly tight. Make sure there's power supply is working, make sure everything's clean, and very importantly, make sure the panel is labeled. This is basically what you need to do when you do preventive maintenance. I hope this has helped. And I'm going to show you at Smart Buildings Academy, we have quite a few programs. Several of our programs deal with this issue: how to maintain, what to look for, what to look at. This is the Smart Buildings Academy webpage, smartbuildingsacademy.com, and we offer all kinds of certifications: technical, master technician, building engineer. This deals with maintenance right here. We have programming certifications. We have designer certifications. We have integrator certifications, sales, project management. The list goes on and on. You can find a course by its name, or if you fill one of these job roles, you can go through and click on it, and it'll take you to what courses are taught if you want to be good at programming, for example. And you go through everything from the fundamentals all the way through how to program. So come to SBA, take a look at our webpage. If you want to improve your building maintenance skills, we have the course for you. We're opening up the Workforce Development Program again, Workforce Development 2.0. It is an excellent course, and it'll take you from zero to hero in no time. Be sure and check this out. I hope this was informative for you. and I hope you learned something about maintenance for your system. If you don't have a maintenance program, I recommend you get one. If you're interested in analytics, find a good analytics department and talk with them. If you'd like for us to help develop your training program, give us a call and we can work with you. I hope you have a great day.